Welcome to the Critical Thinking Workshop provided by EASE Workshop Series. This workshop comes with an assessment that you can access through the EASE website. The link is shown on the screen. If at any point you need more time to process the information presented, pause the video until you are ready to continue. Let's go ahead and start. This workshop will go over what critical thinking is, steps to engage in the process of critical thinking, and will deliver strategies to question information presented by the media, especially when it comes to its portrayal or presentation of science. Adding to that, regardless of being part of a course or not, please take some time to answer our post-workshop survey to give us insight as to what you think about this presentation. Before we get into discussing critical thinking, you should know where you currently stand on understanding the concept. It's always a good idea to assess what you already know and what you think of a topic before you learn more about it. Some describe critical thinking as an analytical way of thinking. It's a way of acquiring information from many parts and connecting it to make educated predictions, conclusions, etc. Critical thinking, as defined by the Oxford Dictionary, is disciplined thinking that is clear, rational, open-minded, and informed by evidence. Keep this in mind as we move forward through the presentation. Let's get your brain warmed up with a basic riddle that will help you reflect on how you think. How do you put a giraffe in a refrigerator? Remember, you can pause this video at any time. The answer is, you open the refrigerator, put the giraffe, and close the door. I know what you may think. How is this question making me think critically? But the point of this is not to say that the answer is utilizing critical thinking, but more that your answer gives insight into how you think. For example, was your answer more complicated than this? Do you do simple things in an overly complicated way? Maybe to the point that you refuse to answer the question because you thought it had to be more complex. What is underlying your thought process? Keep in mind that although in life the simplest answer is not always the best answer, it is a good starting point. So start simple, then make it more complex as necessary. The idea of being aware of your own thought process and strategies is the concept of metacognition. Essentially, think about how you think. Reflect on your own thought process and strategies for building what you think, believe, or do. If you think about it, it's easy to sit through a class memorizing some facts and working through assignments with minimal effort without ever actually engaging with the scientific process that puts critical thinking into practice. It is important that when presented with a concept or task, always ask yourself, why, how, and what ifs about the topic. Something to remember is that learning is not thinking. As Albert Einstein expertly put it, the value of a college education is not the learning of many facts, but the training of the mind to think. Something that most people are not aware of is that critical thinking takes practice, but worry not, there's a method for you to actually develop these skills. There are 6 stages they will go through to start training the brain to become more conscious thinkers. Each of the stages serve as a base for the next. In the case of stage 1, we have what is known as the unreflective thinker. We all start in stage 1, where we are unaware of significant problems in our thought process. At this point, the unreflective thinker is unaware of all the components that critical thinking requires, such as putting together concepts, points of view, reasonable assumptions, and/or the fact that they may have biases or delusions that are guiding their thought process and may affect how they put together thoughts, ideas, and conclusions. Considering this, let's go back to our refrigerator question. In order to answer this riddle, you had to make an assumption, the assumption that a giraffe can fit into a refrigerator. Is this a reasonable assumption? Probably not. However, because this is our assumption, we try to answer the question, and some of the answers following this assumption have been: place the refrigerator horizontally and leave the door open so that the giraffe can stick its neck out, make a hole on the fridge, or maybe it's an industrial fridge, which are very large, and a small giraffe, a juvenile. All of these are good. You made an assumption in attempts to answer the riddle. You are at least a stage 2 thinker, known as the challenge thinker. At this stage, the individual actually recognizes gaps in knowledge where one may have some difficulties connecting information. In the case of concepts, we may not know enough basic information when it comes to a specific subject. We may have a limited view about a topic, not knowing the opposing arguments or evidence. It may just be that we have difficulty making reasonable assumptions because we have no practice in connecting information yet. And in the case of possible biases or delusions, it is important to understand where we currently stand on a topic. So reflect to see if you have preformed opinions and what is the root of those opinions, because again, they may influence our thought process. Let's take a moment to consider how those preconceived thoughts can often influence our response to a question. For example, how do you think the average person would answer a question about where plants get their food? Perhaps along the lines of from the water, soil, and all over. This is because we are driven by our human-centered concept of food. But if we really think about it, the more appropriate response is that they make their own food. So being aware of what our opinions are founded on is an important component of critical thinking. So what can we do to identify our challenges when it comes to critical thinking? First, decide what you think and why you think it. Do you think that apples are healthy? Is it because you constantly heard an apple a day keeps the doctor away? That your parents tell you they were healthy? What information have you come across that actually tells you that apples are healthy? Second, even if a course or topic is presented in a lecture-based format, you can try to expand your horizons past what you already know. You can even generate a list of questions and look for information. If you don't have thoughts about the topic, talk about it with somebody else to see if their thoughts spark something. We are in the Google era, so take advantage and get as much information as you can regarding your views, but also those of others, because tied to this is to think about the topic in another way. Sometimes it helps to play devil's advocate, which consists of you deciding what you think and why you think it, and then switch. Become the advocate of the view opposite to yours. Lastly, you can ask yourself, how do your thoughts now compare to before doing this? In this type of situation, it's healthy to doubt yourself and rethink your conclusions. Consider all evidence without bias. Which position is more valid? Which is more convincing? Which is more realistic? When it comes to stage 3 to 5, they consist of actively thinking critically. This is done only after you have identified the weaknesses and strengths in your thought process. The stage numbers not only reflect the logical progression of thought, but also a ranking for the amount of time you generally spend implementing each process. Explained simpler, it refers to the active exercising of critical thinking when presented with new ideas or subjects. And the more you do it, the better you get at it. Again, engaging in critical thinking can be difficult initially because we are, to put it bluntly, lazy thinkers who are often exposed to broad misconceptions. Unless you practice expressing and defending why you arrived at a particular conclusion and listen critically to those of others, you will not critique your own ideas and modify them, if appropriate, in light of what you've learned. In stage 6, critical thinking has become second nature. It is not a process that you are actively practicing, but rather something that you just do because your mind has been trained to engage in it. To make the point, let me give you a brain exercise. This is an assessment question. Take some time to connect all the dots, but there are a few requirements or rules. You can only use up to 4 lines, and it has to be a continuous line. You can't separate the pencil or pen from the piece of paper. What conclusions can you draw from this? You can pause the video if you need to. This is probably the most common answer. Can you think of another way of connecting all the dots? Well, how about this? You can cut off each dot and glue them in a line to connect them with a single line. If you have it on paper, you can fold it in a way that the line is continuous because you don't put a limitation to the size of the line. The point I want to make is that when engaging in critical thinking, keep an open mind. Think outside the box because sometimes the only person placing limitations in your analysis is yourself. Let's now start connecting this to science. You have to remember science is not the finished product that is often encountered, but a process of trial and error through the scientific method and critical thinking. Science is not black and white with definitive answers, so the scientific process in itself and through peer review helps reduce the probability that our own viewpoints are influencing our conclusions. And sure, we need foundational knowledge to help us in this process, but it's more about the application of that knowledge into a new framework than the facts themselves. Most of the wonderful scientific advancements we have today are a result of blunders or progressive thinking that builds on the foundational knowledge, not regurgitation of facts. When it comes to critical thinking and science, we judge the quality of the arguments, including the reasoning, the assumptions, and evidence presented. We also keep an open mind, since new information may shift preconceived notions. And so as you move forward, be as well informed as is reasonable before taking a strong stance on an issue. We need healthy debates to make us think outside of the box and fill in any gaps in our knowledge or understanding. Okay, so with all of this information, you're probably just thinking, what does critical thinking have to do with science and the media? Let's put this into a practical setting of your everyday lives. Why do you think pop science gets more attention than peer-reviewed science? So it can be something that people want to be true, or it can be something that they want to hear, and it adds excitement and drama. For example, during the Ebola epidemic of 2014 in West Africa, people started burying their deceased wrapped in their bed nets. For your knowledge, bed nets are used to avoid mosquito bites and prevent malaria from spreading. This practice made people believe that the bed nets had to be causing the illness and therefore stopped using them. As a result, malaria cases also increased during this difficult time of disease in West Africa. It didn't matter bed nets had been used for years or that no medical official had provided the information. It's what people wanted to believe, that avoiding the disease could be as simple as sleeping without a bed net. A lot of times, when it comes to STEM-related fields, we encounter many fallacies in the media. A fallacy basically consists of poor argumentation used as fact or evidence to prove a claim. Fallacies may be created unintentionally or they may be created intentionally in order to deceive other people. Sometimes the term fallacy is used even more broadly to indicate any false belief or cause of a false belief. I will mention only a few in this presentation, but if you are interested in learning more, there is a link on the EASE website. Among some of the fallacies the argument may contain are arguments that come from uninformed or misinformed sources, the focus on only one side of the story or limited view of evidence, which is basically cherry picking. The information may stem from urban myths, have no scientific basis, or come from fear, uncertainty, and doubt. And the last three are big when it comes to pseudosciences. If you are not familiar with what pseudoscience is, they are defined as a collection of beliefs or practices mistakenly regarded as being based on the scientific method. Some things to look for to identify the information presented to you as truly scientific are: the source, is the person or entity making the claim someone with genuine expertise in what they are claiming? The agenda, you must know this to consider any information in context. In a scientific paper, look at the funding sources. The language, does it use emotion words or a lot of exclamation points or language that sounds highly technical but that is really meaningless in the therapeutical or scientific sense? How about testimonials? And don't get me wrong, Testimonials can be important in research such as social studies, but if it's the only thing you have for a miracle cream or medicine, you most likely need to look for more data. Exclusivity is also something important. It's quite rare that a new therapy or intervention is something completely novel without a solid existing scientific background to explain how it works, or that only one person figures it out. How about a conspiracy? Claims such as, doctors don't want you to know, or the government has been hiding this information for years. And the last item is the scientific process. This is what takes us from the realm of pseudoscience into real science. Scientific literature, peer review articles, evidence that has gone through many steps of a scientific process. If you're interested in looking at additional information, we provide some links here and also on the Ease website for some videos that address things that can be misleading sometimes, such as stats and circular reporting. The third one is from the Last Week Tonight show with John Oliver, which we will watch 2 clips next.
Science is constantly producing new studies, as you would know if you've ever watched TV.
A new study shows how sugar might fuel the growth of cancer.
A new study shows late-night snacking could damage the part of your brain that creates and stores memories.
A new study finds pizza is the most addictive food in America.
A new study suggests hugging your dog is bad for your dog.
A new study showing that drinking a glass of red wine is just as good as spending an hour at the gym.
What? That last one? No! That last one doesn't even sound like science. For all those reasons, scientists themselves know not to attach too much significance to individual studies until they're placed in the much larger context of all the work taking place in that field. But too often, a small study with nuanced, tentative findings gets blown out of all proportion when it's presented to us, the lay public. Sometimes that happens when a scientific body puts out a press release summarising the study for a wider audience. For instance, earlier this year, a medical society hosted a conference at which a paper was presented comparing the effects of high and low flavanol chocolate during pregnancy. If that sounds narrow and technical, it was supposed to be. There wasn't even a control group of women who didn't eat chocolate, and the study found no difference in preeclampsia or high blood pressure between women who ate the 2 chocolates. So there is no way a study that boring can make it to television, right? Well, wait, because that medical society issued a press release with the much sexier but pretty misleading title, The Benefits of Chocolate During Pregnancy, and because most TV producers just read press releases, this happens.
Turns out if you're pregnant, eating 30 grams a day of chocolate, that's about 2/3 of a chocolate bar, not the whole chocolate bar, could improve blood flow to the placenta and benefit the growth and development of your baby, especially in women at risk for preeclampsia or high blood pressure in pregnancy.
Except that's not what the study said.
You are welcome to watch the entire video on your own time. As you may or may not have picked up, this show in itself can be very biased sometimes, but this segment provided some good examples on how the media portrays scientific findings. When presented with information from the media, keep in mind what is the quality of the evidence supporting the claim. So look at how the outcome was measured. Was there a control? What about the sample size, the bias, reproducibility, or plausibility? If you encounter conflicting evidence, look at the quality of evidence on each side and weigh it appropriately. And lastly, keep in mind that some things are not going to be answered by science. Science cannot answer questions of religion or the supernatural, since it's based on observations, repeated experiments, and evidence to support its conclusions. So let us engage in some active thinking. Take some time to answer this assessment question. Let me ask you, were you initially stumped because you thought of the beggar as a man? How much of that was influenced by your preconceived notions of what a beggar is? Or the image I put up? The media is constantly choosing imagery they know will elicit a desired response from us. This helps highlight how what we are initially exposed to and our preconceptions, thoughts, or opinions often drive our thought process. Now that you know a bit more about how to train your mind and what to look out for, let's look at a few real-world examples. We will inspect arguments from both sides of the coin and look at what makes them weak or invalid. Let's consider the following arguments on vaccination. This is not to determine which side of the argument is correct or which side of the argument you are part of. It is to see how we can apply critical thinking to a statement presented to us by the mass media. This is an anti-vaccine argument. Diseases that vaccines target have essentially disappeared. There's no reason to vaccinate against diseases that no longer occur in the United States. What are some of the critical thinking strategies you can use? Pause the video if you need to. Even without doing additional research on the topic, there are some things to consider. What does the word essentially mean? Why have the disease disappeared? Why is the argument limited to the US when people travel to and from other countries? The statement, "there is no reason," is very subjective. This highlights how information is often selectively presented or misinterpreted. The training of the person making a claim is also extremely important to consider. Let's look at the other side now. This is a pro-vaccine argument. If the doctors and government approve it, vaccines must be safe to everyone. Well, can we assume that everything the government or medicine have done has been safe for people? Also, are vaccines safe for every individual? This statement is very strong and needs additional support for the claim it's trying to make. Let's look at a different example. Let's talk about a hypothetical cancer. I want you to reflect on this statement. This deadly cancer is at least 3 times more common among people who drink milk and has a 50% survival rate. How does that statement make you feel? How much was your initial reaction in response to this staggering statistic? So, thinking critically, what are some questions you should ask? Now, what if I were to tell you that this cancer is extremely rare and occurs in less than 1 person in 100,000 and accounts for less than 1% of cancers in the US? Would you still avoid drinking milk? How does this information change your initial response? I use this example to highlight the importance of watching out for statistics and how it can be used as a scare tactic. Taken alone, some numbers seem very outstanding, but when you look at the bigger picture, avoiding milk decreases your overall chances of getting this hypothetical cancer only by 0.75%. Let's try another example. Let's talk a bit about climate change. Again, the point of this is not to pick sides, but to think critically about any statement that is presented to us, especially in the media. And arguments against global warming is 31,000 scientists say no convincing evidence. So, what is your next step? What are your questions? What may you ask? The statement comes from an online petition where scientists got to check a box stating their degree. This means that the results are not verifiable. And also, the area of study included engineers, medicine, chemistry, biology, etc., not many of who study climate science. This report also failed to mention that of scientists working in the field of climate science and publishing papers on the topic, 97% of the climate scientists surveyed believe global average temperatures have increased during the past century, and 97% think human activity is a significant contributing factor in changing mean global temperatures. So now it's your turn. Take some time to go over the following statement to finish your assessment question. Let's look at the other side of the coin now. Argument 3 says, the entire north polarized cap will disappear in 5 years. And argument 4 says, Our generation has inherited an incredibly beautiful world from our parents, and they from their parents. It is in our hands whether our children and their children inherit the same world. Why are arguments 3 and 4 not that strong? Well, they are focusing on emotions rather than facts, right? Again, pay attention to the source, whether the information delivered is complete, so look at all sides, and if the statements are bringing about strong emotions to persuade the audience. The case studies I presented were from pop science sources. How do this differ from primary literature? Well, the name itself says it. It's the source where the finding was initially described with actual research and evidence to support the claims or conclusions. The main thing to keep in mind is that there should be an original source for the information. If it is primary literature, you should find it and read it for yourself. And use this newly acquired skills when reading the original source. Although primary literature is peer-reviewed, that doesn't mean it is infallible. Regardless of what type of information you are reading, make sure you are paying attention to your thought process and critically thinking about what information is presented to you, even in reliable scientific journals. Now we're going to go over another subject with regards to the media and science. I'm talking about the differentiation between causation and correlation, which is actually very important. But the media often takes advantage of the fact that most people don't know the difference, often assume cause and effect. What do you think causation is? It is when one action is the direct cause of a given result. What about correlation? What do you think it is? It is a relationship between two or more things. Take this graphic, for example. The increase in sales of organic foods is highly correlated with the increase in number of autism diagnoses. When we look at this graph, and if we imply causation, we would be saying that organic foods seem to be increasing the cases of autism, huh? But some of the things you could ask are, what other factors have influenced the increased number of diagnoses? For example, are there really more cases, or is there a higher recognition of the disease, or a broadening of the spectrum? For those diagnosed with autism, was the consumption of organic foods relevant to those families? The point is, just because there is a strong correlation or relationship between two variables, it does not mean that one is causing the effect on the other. So, keeping causation versus correlation in mind, youth with an average grade of D or below were more than 4 times as likely to have used marijuana in the past year as youth who reported an average grade. Here we're implying causation, but we don't really know if cannabis is the cause of the low grades versus students who do not perform as well academically are more prone to partake in cannabis. This is not to say that cannabis does not have mental or physical health effects, but only to point out that there is always more to the story. So be careful with causation and correlation when it comes to the media, because sometimes when a correlation is found, they may say that A causes B, some internet conspiracies may arise, and then later A causes B all the time, which, by the way, A is a killer, and the initial interpretation from the research is lost in the process. Think of singular reporting as a game of telephone, where the information gets distorted as information is recycled from the inappropriate source. I'll send you off with this last question. Knowing what you know about black holes, what do you think would happen if they are together? Well, some possible answers are: the strongest hole will consume the other. There will be a supernova explosion. Nothing, the holes will collide and carry on. Or a new galaxy will be formed with all that energy. Well, guess what? There is no actual answer for this question. Sometimes we fixate in trying to find the right answer, But as you move forward in your careers, you will realize that in the case of science, there is not just one single simple right answer most of the times. What we work on is hypotheses, trying to get a glance of what may be happening with the knowledge that we have. Before you stop the video, make sure you complete the online survey we have. We value your input and are open to suggestions when it comes to examples that illustrate the points discussed here. Thank you for listening.